Hey robot makers, hope you're having a good day so far. So do you want to learn how to make your own Bluetooth remote control using a custom PCB? Then this is the show for you. So let's dive straight in. My name's Kevin, come with me as we build robots, bring them to life with code and have a whole load of fun along the way. Okay, let's get over to our keynote and make a start. I'm going to attempt some live soldering on the show today as well, so stand by for that if you're watching this in the live stream. So yes, previously we're going to have a look at what we did a couple of weeks ago with the PCB design with Fusion 360. We're going to have a look at a review of the PCBs themselves because they have arrived, and we can have a look at how they've turned out. We can have a go at building the remote, having a look at the components that make this up, and learn from some of the mistakes that I made when putting this together. I've only made 2 so far, and they were quite easy to recover from, so you'll learn about that too. And I bought a new piece of kit. I've got a heat gun. I'll not use that today, but it is that I'll be using going forward to do some surface mounted soldering stuff. So I just need to make sure I've got some fireproof material around me, and maybe a fire extinguisher as well, just in case. And then we'll have a bit of a demo of the remote control in action, so you can see it actually working, which is pretty cool. Okay, let me just turn that down there. I always like how it appears on screen as well. And if you're watching this for the live stream, we'll have a bit of a mailbox Q&A at the end as well. Great, let's get to it then. So previously on this channel, we had a look at designing PCBs, custom PCBs using Fusion 360 electronic design. Because you may or may not be aware, Eagle is going to be no longer produced and sold from 2026, and Fusion Autodesk, I should say, are building all that functionality from Eagle into Fusion 360. So hidden away in some of the menus there is all the features and functionality of Eagle. So what we did on the live stream is we built up this very PCB that you see here. I did tweak it a little bit afterwards just to make sure everything was finalized, some holes and so on, everything just as I wanted it. I then sent off for fabrication to PCB Way, who are the sponsor of today's show, and they fabricated this, and I think it was just over a week for it to be shipped from China to arrive at my house and for me to actually build a working remote control. So I'm really, really pleased with how this turned out, seeing as this was my very first attempt. So if I can do this, anyone can do this. So the completed boards have arrived. We're going to have a look at this. They actually come in packs of 5. So I've got one which is working, and I've got these sort of blanks ready to go. So we'll have a look at that in a bit more detail in a second. So if you want to find out more about how I did that, the design, just check out the video link. I've put a link in the description, and I'll comment on a post as well underneath, just so you can see that. So have a bit of a review of what we think of these PCBs. So that, like I said, they come in a pack of 5 minimum, which is pretty good. I think you probably need more than one just in case you mess up some of the soldering or you break one or such. So, and they also have to make this worth their while to manufacture them, because if you only made one, that's quite a lot of effort to set up the machine with the specific type of PCB board that you want. So one of the first things I noticed is just how high quality these are. So like the rounded edges there, really, really smooth. As I run my finger along this, I'm not getting any kind of cuts or any splinters. I was expecting the PCBs to be a bit rougher than this, but they are really, really good quality. Really, really nicely finished, deburred and everything there. And the finish overall, they're very shiny, absolutely perfect as you would hope they would be. All the holes are perfectly aligned where they should be. There is no kind of offset or problem with that. So clearly the CNC machine they used to drill all these things, absolutely perfect. And again, no marks or bits of material left in the holes. Everything's been perfectly machined, which is what we'd hope to happen. The pads and the silk screen, everything is, again, as we would expect. All these pads are perfectly silvered, ready for soldering. So I don't know if you can see that in the light there. But yes, they're absolutely as we would expect them to be. See all the little tracks there as well. And the actual silk screen with the I don't know if you can see this on screen there, but I've got some little words there. It says up, down, left and right, so I can see where the actual buttons go. And we've got A, B, X and Y, and we've also got the voltage and ground, which goes to the Pico to power it. So yes, all of these things worked. I checked them out with my multimeter just to make sure everything was sort of electrically complete. And of course it works as you would expect. And the boards are very solid, very durable, pretty pretty chunky actually. I've got onto the specs I think on the next slide but one, but yeah, very impressed overall with how these came about. I'm very impressed with how quickly they came manufactured as well. You can see I've gone for the yellow color of PCB there. The solder mask is sort of yellow colored. Okay, so which options did I choose? This is what I went for on the PCBWay website. So the size is about 180 by about just short of 80 millimeters, and that's because it's looking at the sort of rectangular size. So anything that's sort of cut away there, you don't get those pieces, you get it just as you design it. But you can see this is a completely custom size. It's designed to look like an Xbox controller or something like that. So when you hold it in your hand, you've got a nice thing to hold in your hand, and it works well. So it comes as you would expect there. It's 2 layers, so there's just a top layer and a bottom layer. You can go for a lot more layers if you want to have those sandwiched on there. I just went for the simple 2-layer option. It's 1.6 millimeters thick. So as if I got my calipers on that, 1.6 millimeters thick, and the minimum hole size is 0.3 millimeters or up. So I think the very smallest size I've got on here, I'm not sure I've got any vias on here. So it'll just be the actual holes for the parts, which is the legs of the momentary push switches, the tack switches. The silk screen I went for is white, so all the text and the artwork on there is white. I've not actually gone for any artwork. That's something I'll do on my next version, no doubt. And what else is there? So minimum quantity was 5, so I went for that. The material is FR4 TG150, if you know what that is, and that's just the type of like fiberglass material or whatever it is this is made of. So FR4 is the name of that. What else we've got on there? The solder mask, like I said, is yellow. I decided to go for something a bit different. I was toying with black or the basic green, but I thought yellow would be interested. It's not an edge connector, so there's no kind of solder that goes to the edge or beyond. And the copper finish, I was interested in this. It uses an ounce of copper, which they use to sort of do the fill on there. And obviously it's not been added on the back there because I didn't actually add one of those. So yeah, very impressed with how these have come out. So it wouldn't be a video sponsored by PCBWay if I didn't actually do some kind of a sponsor message. So here we go. Here's the sponsor message from PCBWay. This video is sponsored by PCB Way, your ultimate destination for all things PCB manufacturing and assembly. Whether you're a hobbyist, a startup or a seasoned professional, PCB Way has got you covered. PCB Way offers an impressive range of services. They provide high quality custom designed printed circuit boards for any application you can imagine, from single layer to multi-layer, flexible and even rigid flex PCBs. They have the expertise to bring your designs to life. PCB Way ensures fast turnaround times and affordable prices without compromising on quality. With their state-of-the-art facilities and advanced manufacturing techniques, they can handle small prototype orders up to large-scale production runs with equal precision and efficiency. PCB Way offers additional value-added services such as PCB assembly, component sourcing, and even functional testing. You can trust them to deliver the fully assembled and tested boards ready for integration into your projects. One of the best parts of PCB Way is their user-friendly online platform. It allows you to easily upload your designs, get instant quotes, and track the progress of your orders in real time. Plus, their dedicated customer support team are ready to assist you with any questions or concerns. So whether you're working on an innovative Internet of Things device, a robotics project, or anything in between, PCB Way is your go-to partner for reliable and affordable PCB manufacturing and assembly. Head over to PCBWay.com today and turn your ideas into reality with PCB Way, your trusted PCB manufacturing and assembly partner. So thank you to PCB Way for sponsoring this video. Quite an appropriate sponsor as well, I would thought. So this is how it came in the packaging, and I'll show you the total cost for this as well. So it comes in a nice little cardboard box. It comes in bubble wrap as well. It's sort of heat shrinked into that as well, so there's like absolutely no air gaps around the PCBs. There were some labels on there with the product number and all that kind of stuff. It also had my address on there, and I didn't want to share that on the live stream, so it didn't look tatty like that. I've just ripped them off very badly. And then yes, the total cost then, so the PCBs themselves were $38.96, and it depends on what you have, how many operations I guess their CNC machine has to make on that. So depending on how many holes you've drilled, how many pads you've got on there, how much copper's used, the size of the board, the colour of the mask, the amount of white silk screen stuff you've got on there, or whatever colour you choose. So mine was $38.96, and then the shipping was almost half that. It was $18.42, so the total there was $52.38 to get that shipped across. So yeah, thought you'd be interested to know that. So to add the components to the board, I've got the finished one here, which I can show you. So there is 8 tactile switch buttons. So these are these little, I've got a box full of them here, momentary switch buttons. They're through the hole, and there's 8 of them in total. So I've gone for like an up, down, left, right, A, B, X, Y on the other side. The Raspberry Pi Pico is in the middle there. That's Pico W because it has the Bluetooth component on there. I've also got a little JST PH connector on there so that I can connect up a power battery. I've actually got a LiPo Amigo Pro there as well as a gallium battery. So the idea with these would actually be stuck somewhere like this on the 3D printed enclosure, which I haven't printed yet. But yes, very, very straightforward connectivity there. And there's only a couple of points to solder on there. It's just where these buttons connect up to the Pico. Now, somebody did mention online, why don't I have any kind of debound circuitry in here? You typically have like an RC filter, which is a resistor and a component in line to slow down the reaction between you pressing that button and the electrical signal reaching the GPIO. And the idea there is when you press that in, there's a moment before it actually makes a direct connection and completes the circuit, closes the circuit, and you kind of get, if you looked on an oscilloscope, you get kind of a spiky thing, and depending on how you press that, it might register as 2 clicks for each one. But we can sort that out in software. And I reached out to Pimroni, some of my friends there, to see how do they do it. And they do the exact same thing I've done here. So they have a pin, a button that goes direct to the GPIO pin. They don't use any kind of filter in between there. So I'm following good practice there, I think. So that's fine. Okay, so that's how we put this together. And then software-wise, I've previously written this software. I think I covered this on a previous show as well. So this is 2 parts. There's 2 pieces to this. There's the robot code. So the robot code, which I've loaded onto the Pico on this robot here. This one will listen for direction commands. So it will also listen for Bluetooth devices. And once it finds one, it will automatically connect. There's no kind of pairing required. It's very, very simple to do that. So I've just registered this now. And if I switch on this remote control here, this has got another piece of code on it, which is the remote code. So I just press the on button there. You'll see that that flashes quite quickly, and once it's connected, it'll slow down. And if I press that button there, you'll see that the if I get that on there, if I press that, you'll see that the wheels are moving around there in response to that button being pressed. So very, very simple code to get this working. If you want to get the code, you can head over to github.com/kevinmcaleer/pico_ble_remote, and you'll see both parts there. There's a robot code, robot.py, and remote.py that you'll need to copy. Very, very simple to get these things working. So I've actually preloaded that code as well onto another Pico. So I've got another Pico in here ready to go. So we'll have a go at soldering this up a minute on the stream. And the way that I'm going to do this is I'm going to essentially surface mount this onto here. I'm just going to put a solder on the very bottom pin there, and that will hold it in place while I solder the rest of them as well. And I've got some helping hands here to help me hold this in place. So we'll see how that goes in a second. Okay. So if you like what I do and you want to help support the channel, the easiest way for you to do this is to press the like button. That sends signals to the algorithm to say that this is a video that you've enjoyed watching and that other people might want to enjoy as well. If you want to comment on the video as well, that also helps with the engagement. That also tells YouTube that you like this video and that this video should be shared amongst more people. And the thing that you can do that will really make me happy personally is to subscribe to the channel. If everyone subscribed to the channel that watches the videos, I would have over 1.5 million subscribers. But I'm not quite there yet, so help me get just to 20,000 subscribers simply by clicking the subscribe button if you're not already subscribed, and that'll help me get there. It means a lot to me personally. Okay, I do go live every single Sunday at 7 o'clock GMT. I'll also try and squeeze in a midweek video or a video at weekend as well, which is like a pre-recorded one. I did one today, which was the how to do over-the-air updating with Raspberry Pi Picos and Bluetooth and... sorry, not a Bluetooth, with Wi-Fi and MicroPython. So yes, I do go live every single Sunday, 7 o'clock UK local time. Okay, so I did make some mistakes with these PCBs. They're very, very simple mistakes to make. So when we did the show, we did the live show of actually putting this PCB together. I didn't specify how big the holes were in the pads. I just went with the default size. And that meant that if I get one of these boards, let me just grab a Pico, this one's a regular Pico, and I try and push this through the holes are too small. So it won't actually push into there, and that's because I didn't specify the drill size hole for these to go in there. So rather than having ones with pins on them, so this one has got the header pins. If I just hide my face, it'll zoom in a bit there. You can see this has got the pins there. These don't actually fit into these holes, but not to worry, we can simply just surface mount this just by putting this in the correct place like so, and then just making sure we've got plenty of flux there to run the solder through the hole onto the bottom of the board to make an electrical connection. That should be fine. But in future ones, I'll definitely make sure I've got the right size hole so I can do through the hole components. It does make soldering a little bit easier if you're doing that. The USB connector is also a little bit too far inwards. So when I try and connect like let me just grab a USB cable here. If I try and push this into here, the actual piece of like rubber, plastic, whatever, is catching on the edge of the PCB there. I don't know if you can see that. So if I have that sort of aligned a bit better, as it's going to be, yeah, that doesn't sort of connect in very well. And the very first time I did this, I actually pushed it that hard that it lifted up, and it might have torn away some of the pads on the PCB. I did resolder them, and most of the buttons work, but one or two buttons don't work, and I think that's because I've actually lifted the pads away from the track, and it's essentially just torn that away and ruined it. So I either need to make this sit a little bit higher and have it on sort of blobs, or basically just I could try drilling with a manual drill, but if I did that, I'd essentially just drill away all the actual soldering, and the solder that goes straight through the board is like a via onto the other side as well, so that would also ruin that. And some of these ground connections need to be connected to the other side of the board, so that wouldn't work if I just tried to drill them through. But again, like I said, it does actually work. We've just seen the board working in action there on the one that I've put together, but we'll try soldering on and see if we can get all the buttons working as well. The other thing as well is the power lines could probably do with being a little bit wider. So they are a really small, really small side. They go all the way up to the top there, to the, is it the V-bus or the V-sys, the very top of the Pico. And there's also the ground one on the other side, which just goes to one of the ground pins. And all the ground pins are connected together there as well by tracks on the back side. So really they should be a little bit wider, just because if it's been used for an extended period of time, those tracks might heat up a little bit depending on how much current's going through there, but there's not a great deal of current going through, to be honest. We might be able to get away with it with this particular board, but in future I'd probably make those a little bit wider as well. It also helps with the sort of heat dissipation, is that the right word? So I did buy a new toy this week. It's I think this one is an A10 858D Plus, which is a heat gun, and the idea of this is it heats up air, and you point this at a surface mount with all the components on there, circuit board. Use some paste like this one. This is some what's this called? No Clean SAC 305 lead-free solder paste. So the idea of this is that it's got like this very sharp needle thing on it, and you can put a very small amount of paste onto the PCB. So you put it onto the pads, and then you'd place very carefully using some tweezers the surface mount component, and then you can then put the heat gun at it. It melts the paste and then essentially solders the thing in place. And the temperature is nowhere near as high as like a regular soldering iron. I'm just going to switch my soldering iron on actually so we can do this in a second. And I'll probably need to plug that in as well. I think I've not actually plugged that in. I'll do that in a second. So yeah, the PCB paste essentially holds the component in place just with its tackiness, and then as you put the heat gun on it, it melts it and then solders it in place, and there's no other residue remaining once you put the heat gun at it. It all basically just goes up into the environment in which you're in. So that's what we've done there. So I'll do a bit of a remote control demo, and then I shall do some live soldering, so that'll be fun. So let me see which the best way to do this is. If I go to the overhead camera for a second, just move this around so you can still hear me. So I've got this robot here. This has already got the the code loaded on it, the robot code. If I press that little button in there, if I just remove this, you can just see that there's a Pico in there. And when I press that button on and off, so it's on now, what it's now doing is waiting for a connection to be made. So it's waiting for another Raspberry Pi Pico with the same Bluetooth code on, waiting to connect to it. So if I just put that down there for a second, let's just give it some room to maneuver. Move some of these out the way for a second. And let me see if I can get this to work right. So then we're simply, I've got this Pico gallium battery here, a LiPo gallium battery here. The Pico's on there, it's all connected up electrically. If I press this on button here, you'll see that there's a flashing light there, and it flashes fast when it hasn't got a connection, and once it's got a connection, which is to this robot here, it flashes about once per second on and off. So that's how we can just visually see that this is actually working. And the left button is working fine, so if I press this, we'll see that the robot will jolt, turn that round, it'll jolt sort of backwards and left. There we go, it's kind of spinning round. Probably need to just change the code so that it actually does turn left rather than just spinning round backwards, but we can see that working there. If I press any of the other buttons, I don't think they're working because of what I said before, where I've torn that away from the pads when I connected up the USB cable. Now you can actually plug the USB cable in if you're quite careful on this. If I plug this in like so, there's a point where it does go in, but you do have to sort of hold it in place like that without it tearing away, and that means you can program it. But I've come up with a better way to program this now using the over-the-air updater, which is the code that I did on the video just before this live stream. So that's what we're aiming for. We're going to have a go at recreating that in a second using this soldering iron. I've got a Weller solder station here. I thought I'd actually plug this in, which I've not, so I just need to grab a power cable. There we go. Right, so that's going to now heat up to about, what is it, about 380 degrees, I think it is. And I'm just going to put some water into this sponge here, just in case we need to clean the nib. And we'll just get these helping hands. If you're watching the count of how many things I drop per episode, it's probably going to go off the scale today, so you've got that to play with. Right, so let's just grab this like so I can work on that and that you can see it. Okay, so it's got to 388. And the other thing I'm going to do, I'm going to put some flux onto the pads. So let's just get this. I've also got some lead-free solder. So I'm just using this lead-free solder. And what I like to do is just use the end of the solder to just get a bit of this flux. It's quite tacky looking in there, quite chunky. And then I'll simply just make a bit of a mess on here as these. Try and get it as close to the hole as possible. It's not always possible. Like so. And this will just help the solder run into the hole and make a good connection. So there we go. Now it's only these ones here that we need to worry about, to be honest. I'm just going to do one at the top, one at the bottom, and then these holes here as well. There we go. Yeah, somebody says get the Dremel out for the notch. We could certainly do that. That won't be a problem. You can also just cut away the end of the USB cable as well. That's another option. Right. So what I want to do then is I want to get the Pico, which just flew off. Where did that go? And I'm just going to check that this has got the right code on it before we commit it to the board, just because of the reasons we've just said. So what I will do, I will just plug this into my computer. I'm going to load up Thonny. I'm just going to go back over to me for a second. I'm just going to load up Thonny and just check that that has got the right code on it so that we know that we're good to go. So if I just, yeah, that wasn't the correct one. So where did that one go to? It fell on the floor. There we go. Right, so if I just plug this one in, I should see that it's got the remote control code on it. And if it hasn't, then let's just, so remote control is the name of the file that we want to save on there. So we do save as copy. And we save it onto the Pico as main.py, like so. And if we now reset this, so let's just do import machine, and then do machine.bootloader, that'll effectively reset the thing. Thonny always does this weird, oh, everything's gone wrong. But if I now look on the Pico itself, let's see if this is going to do what it needs to do. Let's just power that up. It should start flashing its lights. However, it isn't doing that. So let's just stop that and see what's going on. If I run the remote control, let's see what happens there. So it isn't actually flashing its LED yet. So what have I done wrong there? Is it remote control or is it the robot? It is the remote control. Let's just try remote. I did this a second ago and it worked fine. So not sure what's going on there. What I will do then in that case, I will reset this and flash onto it MicroPython. So let's just make sure we've got MicroPython on there. So if I go to install MicroPython, I like to use the Pimoroni libraries with Pimoroni libraries because they have the button class in there, and that's really useful for using your remote control. It just takes a couple of seconds for it to do that. So Cassie says the Thonny wigs out on her PC as well. So it's not just me that this happens to. I always think it's like a really bad bug that they have there that does that, and I thought it was just my my computer that did this. So Shemi was saying, get the Dremel out to make the notch for the USB. Okay, so we've now installed the latest version of MicroPython on here. So let's just try running the remote control code again. So let me just stop that, restart it. There we go. And it's got its flashing light as well. So if I just turn the robot on, I've got the robot here. If I press the on button, you'll see that it'll say connected. And that means that it's made a connection to the robot itself. So let me just make sure that's, there we go, turn it off, turn it on. So there we go, connection to that device. And then if I press that off, it'll then say not connected again. Right, good. So that's the one that we should use. So I'm just going to disconnect that. I'm going to quit Thonny, and we'll go back over to me, and then back over to the overhead. Right, so we want to get this pretty much in place where it's going to go. So I'm just going to move the microphone a bit closer there so I can see. Trying to make sure I've got it perfectly aligned the way I want it to be. There we go, that looks good. And it's simply just the flux that's holding it in place at the moment. So the first thing I'm going to do, I'm going to get my soldering iron and I'm going to solder in place that very bottom pin there. So what I will do, a bit tricky to do this with the microphone in the way as well. So let me just try and get this all good. And there's always a bit of paste on there we just need to get rid of. So let's just get that out of the way. Right, so if I just put that onto there. It did move ever so slightly then. A bit more solder on that. And then I'm just going to hold it in place there and let it run. And then I'll do the top right one, and that should anchor the Pico in place. Sorry if I'm yelling into the microphone here, but it's very close to my face. There we go. Now what I'll also do, because these are castellated, I'll just do a little bit at the side as well. There we go. Right, so let's try and get this all soldered up. Oop, It's a bit of a foo bar there. Let's make sure that's in place. That means that it's not getting through to the bottom of the board yet. Okay, let's try the next one. I'm only going to solder the ones that have actually got a connection on there. So what I might do, if it's still not making a good connection on there, which it isn't, I might use some extra flux so that it actually runs into the hole. So let's do that. This is why they actually send you 5, because if you make a mess on one of them, you can always go back and to redo it. Let's just get the flux so that it's just in the holes. And it should run down into where we need it to be. I'm not the world's best solderer, I'll put it out there. Right. Okay. Right, so let's try those other ones. Let me just make sure that's as good as it can be. Let's get above there. Right, let's try this again. The file's still moving. It has actually soldered that in place there, so that's good. That means that that's got a solid connection. Let's just try these. And then let's just try that again. So let's just make sure they're connected. Okay. Right. That'll be good enough for now. Right, what we also need to do is put some buttons on. Let's grab a couple of these. Let's put the soldering iron back for a second while I just maneuver these into place. These are a bit easier to do because they have a physical connection. So if I just push that into place. And what I liked is these came straight out of the Fusion 360, was it the Spark Fun library? So we could trust these are pretty well designed. So the spacing is just perfect, holding it into place just by friction, and the fact that these are kind of like spring loaded. There we go. So if I now just flip this over, and let's just put a bit of flux on the back of these. Now I do have some defluxing spray that I can tidy the board up with afterwards. It kind of just sprays on and you can then just wipe off any of the residue. If you don't wipe it off, you end up with some horrible kind of rust kind of pattern on there. I'll show you what it looks like. I've got a board next to me that's hasn't had the solder paste removed. You can just put some isopropyl alcohol and that will get rid of any of the rust that's built up on there. If you've got a wire brush, that can also help. Right, okay, so let's try these. So let me just get a bit of solder on there. Right, let's just get these soldered. The other thing I've noticed you have to watch for as well is the soldering iron. This box here, every now and again it will time out and then cool itself down. And the idea there is if you left that by accident on, after 5 minutes it will reduce the temperature down and then switch itself off. But if you're in the middle of doing an operation like this, then you notice that the solder isn't melting properly, it's probably gone into the standby mode. So just pressing that volume, the power up button, the temperature up button, resets that timer. Right, nearly done. Okay, I think that's everything done there. I'm not going to do the other buttons on the other side because these ones are the ones I want to test out. Right. So what I'm going to do, I'm just going to turn off that solder for a second. It does look a bit skew-iff on there. I'm not sure if that's going to work okay, but let's give this a go. So how are we going to do this? Let's have a think. So I've actually not plugged in any power to the board, so we need to just provide some power to it. What people saying, Alex, in the comments?
That the stream went to 140 pp.
All right, it seems to be pretty consistent now, actually. Right, so I've got my bench power supply switched on. I don't know if I've got this zoomed in or out. If I move this to one side, goodness sake. Right, if I now go to this one here, so I've got my bench power supply, I've got it on 5 volts. Now the really weird thing with these power supplies is the way that you change the ampage is you actually short it together to change that. So if I just short these together, I always think that's like the worst thing you want to do. And then let's just change the ampage, because I don't think we need 1 amp going through there, so let's just make it down to about half that. Right, okay. So what I will do then, I'm going to apply some power to this and let's see what happens. So I'm going to put the voltage at the top there and then the ground. Let's see if we get anything coming through there. So far not. So let's test out the electrical connectivity. So the way that we do this, I've got my multimeter here. Let's go back over to this view here, it might be easy for you to see. So this multimeter has got this what do they call it? The mode where you can see if things are actually getting an electrical connection or not. Continuity mode, that's the word I'm looking for. Right, so if I go between this pin here and this pin here, is this running out of batteries or something as well? Yes, of course it is. Right, so just bear with me a second. This is what happens on live streams. You never quite know what's going to happen next. So I just need to go and change the batteries in this. And of course they make this incredibly hard to do. So what do I need to do in there? I need to get a screwdriver in there. And then I want to check the continuity to see are we actually getting a connection between those 2 pins. It might be that the board's just a little bit off. It was a bit hopeful trying to be able to do this on a live stream with a camera in the way. Right, so this is a 9-volt battery, okay. I think I have some 9-volt batteries somewhere. a 9-volt battery. Let's plug this in and see if this one works. Should have checked this before the live stream, but I didn't think ahead for that. Just assume that this bit would work. Yeah, this says okay. And then we can check the continuity between all the different connectors on there and see if we can get this up and running. Okay. Right, let's try this again. So let's go back over here. Let's connect up our multimeter. And if we just connect the two together, we should get a buzz. If you can hear that very, very weak sounding beep when I do this. You hear that? That means that there's a continuity between these two connections. So if I get a freshly made board and I go between the power and the voltage, so I'm actually not getting any connection there. There we go. So I probably need to heat that up a bit further to get that connection to be solid. Interesting, this is what happened on the first one. I had to resolder it a little bit. So let's just heat up the soldering iron in a minute and then see if we can get that to work. And let's just test out some of the other connections. So if I go between that pin, that one, that's fine. How about the other side of the button and ground? Let's just place on a ground. So we're not getting that on the ground. Yeah, so I think I'll probably have to resolder this one entirely. It's ever so slightly gone skew-if, and that's meant that the connections are not making good connections on there. So I'll probably just have to unsolder them. So I don't know if you've ever unsoldered things before. The way to do that, let's just unplug my power supply. Plug our soldering iron back in. Wait that to come up to temperature. Okay, let's just... There we go. So I've got this desoldering wire, and what this is like a braided cable made of copper. It looks like a fish kind of scale. If I zoom in on this, let's see if I can get this to zoom in on me a little bit. Come on. Might even be easier to do on the other camera actually. There we go. You can just about make out there. It has like a braid effect on there. So if we apply this over the top of our board, let's try that. I'm going to try that one just there. Let me move this over. I'm going to try that very top one there, for example. So what we do, try and do this without burning myself as well. So let me just grab that soldering iron from there. So we put the braid over the top and then we just push onto it, and the solder will melt into the braid and it extracts it from the area. Just try that. Let's try a few of the other ones, maybe that one there. That is quite thin braid, this. Maybe I need some slightly thicker. There we go. And then once I've done all that, I can then resolder it. I'll not do that on the live stream because I think that's a bit, I'll be here all night making a mess of that. But I've got a couple of other boards to have a go at. So the other gadget for desoldering is one of these solder suckers. So these are quite satisfying. What you do is you do the plunger down, you put your solder iron to the thing that's got the solder on it. See if I can get this to do it. Say that one just there. You wait for the solder to melt. You get this right in there and then you do that. Let's try that again because that did work. And then when you push the sucker, it'll spit out a tiny piece of solder. Let's try this one on the very end over here as well. Bit tricky to do whilst. There we go, that one really did get it then. So if I now just show you this as it spits out into my hand, there's like a little piece of solder that it's extracted just using suction. So get yourself a solder sucker. This one is a quite a nice one. Engineer, what does it say on there? Engineer solder sucker. Very nicely manufactured. Cool, so yes, that's how we can unsolder things if we make a bit of a pig's ear of it. Cool, let me get back over to the keynote and we can carry on. So we did have a bit of a try at surface mount soldering, hence the sweaty emoji there, because I knew that would be quite a tricky thing to do, but I wanted to have a go and show you. It's not the easiest thing in the world to do, and that's why I've got the heat gun and the solder paste, which I've put somewhere, and I can't remember where I put that now. It's probably on the floor somewhere. It's in a little bag, there it is. So this solder paste, interestingly, it says store this refrigerated. I don't know if that's after use. But yeah, this solder paste is pretty heavy actually, that. You can see this. This is no clean lead-free solder paste, and it has a little nozzle that goes on the end there. Looks like a hypodermic needle kind of thing, and yeah, you kind of push that into the place there, and then you can get a really fine amount onto the surface mount, and then you use your heat gun. Very carefully use your heat gun because you don't want to blow it away or burn anything in the surrounding area, hence why I need to get some kind of heat-proof mat underneath. And then we can try with that rather than using a great big soldering iron to do stuff like that. So hope you enjoyed me attempting to do that. I wanted to give it a go to see how that would go. It might have been fine. So if you want to learn more about how to build robots, learn MicroPython, what else we've got there, learn databases, learn 3D design, then head over to kezrobots.com/learn and you'll find all the free courses that are available on there. And I have been doing some work on KezRobots. If I just go back to me for a second and just load up kezrobots.com, I've added a bit better navigation on here, so it's a little bit easier to move around and discover things as well. So if I just go back over here, let me load this up and show you what this looks like. So yes, we're on kezrobots.com, and if I go over to, for example, the Bluetooth remote control PCB, you can see there we've now got this blue navigation bar, so you can look at all the latest blogs, such as those there, or you can click on all blogs to get all the blogs, for example. It's all organized by date. And if you now go over here, there's a much easier to use navigation. So we go to the free courses, you can see all the courses that we have there. And I have these learning pathways. So if you want to learn robotics, you can click on that one, and there's a series of courses which I built which all relate to that particular learning pathway. Just move that out of the way, there we go. And you'll see there that we've got Robotics 101, Python for beginners, Learn MicroPython the basics, Raspberry Pi Pico, MicroPython GPIO mastery, and then this one there about robotic eye mechanism as well. So that's on the robotics gateway pathway. If you want to learn Python, then we've got the Python courses and so on, 3D design, and I'll add to that the new 3D design. So I've got a little invisible window that you can't see here, and it keeps getting in the way of me clicking things. There we go. If I click on that one, we'll then load up the 3D design courses. You can individually take the courses as well, and if you click on them, it goes straight into the course. There's no sign up required. You can just start using it straight away. So hope you find that of use. So that's the kezrobots.com/learn. And we have merch, so you can buy merch to support the show. It's the best way to drink your coffee is by getting a KevRobots.com cup. And I'm also going to be putting into the store once I've finished it, and I can't see it anywhere. There we go. Right. Robot Maker's Almanac. Let me just get this into a nice order, and I'll show you what this looks like. It's a bit of a slow burn one, this one, because there's a lot of content that needs to go in it, and I need to be able to have time to do this. So this Robot Maker's Almanac is a bit like field notes, and in here you'll have all the information you need, like all the GPIO pinouts for your Pico, or for your microbit, or for, what else do we have on here? We've got all the resistor codes. We have mechanism wheels, how to arrange those correctly. We've got the Raspberry Pi 2W dimensions. We've got the all the electrical symbols are on there as well, and there's going to be a lot more in there too. So these will be on sale when I finish putting the content in there. But for now, you can go over to kevrobots.com/merch to check that out. If you've not joined our Discord server, then you need to head over to kevrobots.com/discord and join the community of people there. There's a really great community of people, and you're missing out if you have not become a member of that. If you want to follow me on social media and see all the things I'm up to behind the scenes, then you can go to I'm at Kevin McAleer at threads.net on Threads. I'm using that quite a lot. I know a lot of people have moved over from Twitter onto Threads. It's got a lot more going on for it than Twitter at the moment, as they seem to be putting more and more restrictions in place on there. We have Kevin McAleer 6 on TikTok. I do post a lot of videos onto TikTok. I'm also on Instagram at Kevin McAleer, on Twitter, now X, Kev's Mac, and on Mastodon Social, I'm at Kev's Mac at mastodon.social. So you can find me in all those places there. And if you want to support me, if you want to go more than just follow me, you want to actually support the show, you can get your name in the end credits. So you can do that by going to kevrobots.com/coffee, or by doing a super thanks, a super chat, or joining the YouTube membership program by clicking the join button beneath the main window player there. So I have a number of people who have already done that. So let's give those people a shout out now. So we have somebody bought me a coffee. They wanted to remain nameless, so they're nameless. We've got a new subscriber, a new member, which is Adam from Haunted Haworth. I've gone on quite a few of his tours up in Haworth, the Bronte country. He does those, I think, most weekends, so definitely check him out. We've got Dean Corty, we've got Marlene Brent, John Rank, Tom Shemmy, and Steve Phillips. And then on the YouTube membership side, we have Tinkering Rocks, we've got Dale from Hybrid Robotics, we've got Cassie, hi Cassie, we have JDM, Johnny Bates, Bill Hoy, Oxrad39, Jose, Javi Gold, we have Hans from Cheerlights, Michael, and of course we have Tom as well. So I think that's everything I've got for you in the main show today. Yes, it is. So it's at this point in the video where I'll say thank you so much for watching, and I shall see you next time.